Have a nice time, Don. Welcome to the third lecture of complex analysis, in which we will discuss conformal mapping of analytic functions. So, what do you mean by a conformal mapping? Before going to the concept of conformal mapping, we will discuss what you mean by a mapping of a complex function. Suppose you have a map W equal to f of z. So in the z plane, that is in the xy plane, suppose you have a point, let it be 1, 1. That is, it represents the complex number 1 plus I. And suppose you have the map W is equal to 2z. So this point 1 plus I will map to the point 2 into 1 plus I. That is equal to 2 plus 2i. So corresponding point in the UV plane is, or in the W plane is, so actually we will always represent Z as the complex number x plus iy and W as the complex number u plus iv. So in the UV plane, the corresponding image is the point 2, 2. So this is the point 2, 2, or this is a complex number 2 plus 2i. So this is what you meant by a mapping of a complex number, complex function. So this is what you meant by a complex mapping. So when you draw a function of one variable, suppose it is y is equal to a function of x, you can represent the map in a single plane. If you have a point in the x-axis, let it be 1, and if the function f of x is equal to 2x, the image is 2, the image of the point 1 is 2 under this function, and it will represent the point here. Okay, so this is the point, this is a height f of 2. So in the mapping of real functions, it is enough to use a single plane. But for complex mapping, what happens is, when you represent a point z, it is actually of the form x plus iy, and to represent this single point z, we want a plane. Okay, so you want this z plane to represent points in the z plane, and the images are lying in the w plane, and we want another axis another plane to represent the images of the corresponding points of the z plane. So here this is z plane and this is a w plane. And for each point in the z plane, we will map the corresponding points in the w plane. And this point is called the image of the corresponding point in the z plane. Now, suppose you have a line y is equal to x in the z plane. Okay, or it's a function, it's a image of the function f of x is equal to, y is equal to f of x equal to x. Okay, so let us see what happens if you find the image of this line under the map w equal to z. W equal to z means that u plus iv is equal to x plus iy. So that means that u is equal to x and v equal to y. So the corresponding image of this line in the w plane becomes the line itself having a slope of 45 degree with a u axis. And this is actually the line v is equal to u. So under this map, what happens is, we are mapping each of the points here under this map, and we draw the corresponding image in the w plane. And if you draw the image of all the points in this line, we will get the corresponding image in the w plane. Since the function here is w equal to z, the line y equal to x is mapped to the line v equal to u in the w plane. Now, what do you mean by a conformal mapping? A mapping w equal to f of z is conformal if it preserves angles between oriented curves in magnitude as well as in sense. So in this figure, you can see that the angle between these curves, that means that the angle between the tangents at this intersecting point, it is alpha. And here C1 star and C2 star represents the corresponding images of these curves in the w plane. If you have the angle alpha itself here, if the angle between C1 star and C2 star also equal to alpha in magnitude and in direction, we can say that this is a conformal mapping. So it means that the angle alpha, where alpha lies between 0 and pi, between two intersecting curves C1 and C2 is defined to be the angle between their oriented tangents at the intersection point Z0. And conformality means the images C1 star and C2 star of C1 and C2 make the same angle as the curves themselves in both magnitude and direction. Then we say that this such a map is a conformal mapping. Now some problems. Sketch or graph the given region and its image under the given mapping. First problem is mod z less than or equal to 1 by 2. First note that mod z minus a equal to r represents a circle with a center at the complex number a and radius r. Now it is given that mod z less than or equal to 1 by 2. So in the place of a, here you have 0. So we are here considering a circle with center 0 and radius r. And it is given that mod z less than or equal to 1 by 2. That means that we are considering the interior of the circle. So first of all, you have to draw the interior of the circle with the radius 1 by 2 and center 0. So this is a center and radius, let this point be 1 by 2. Now the region given us mod z less than or equal to 1 by 2, that is interior of this circle, together with the argument of z lies between minus pi by 8 and pi by 8. Pi by 8 means here from here to here it is pi by 2. Half of this is pi by 4 and again we are making the half. Actually it's like this, and we can draw the corresponding line here. So this angle is actually pi by 8. Okay, so the argument lies between pi by 8 and minus pi by 8 means that minus pi by 8 you have to draw from in this direction. This is the line theta equal to minus pi by 8 and this angle is minus pi by 8. So the region given us, the argument lies between minus pi by 8 and pi by 8, and we have to consider all points in the interior of the circle mod z equal to 1 by 2. So actually we have to consider this part. This is the region given in the z plane. Okay, you have to find the image of this region under the map w equal to z square. So W equal to Z square means you have U plus IV equal to X plus IY square. Or you may consider this as R e raised to I phi. It's a complex number representing W and this is equal to small r e raised to I theta whole square. That is Z square. And you may note that capital R is here corresponding to small r square and phi is equal to 2 theta. Because this point is r square e raised to 2i theta. Comparing these two complex numbers, the amplitude is capital R and small r square itself, equating the two, and the corresponding arguments are phi and 2 theta here. So phi equal to 2 theta. So under the mapping w equal to z square, what happens is the amplitude of the complex number w becomes square of the amplitude of the given complex number, and the argument becomes double that of the first one. So we have to find the image of all these points in this region. Now we will consider the image of the region mod z less than or equal to 1 by 2 and minus pi by 8 less than argument of z less than pi by 8. Okay, so under the map w equal to z square, what happens is this amplitude becomes square of the amplitude of this one, and so we have mod w less than or equal to 1 by 2 square, that is 1 by 4, because here r becomes small r square, here small r is 1 by 2, so you have the images mod w less than or equal to square of this one, that is 1 by 4. And again what happens to the argument is it is 2 times the argument of the point in the z plane. So you have 2 into minus pi by 8, that is minus pi by 4 less than argument of w less than pi by 4. 2 times pi by 8, that is pi by 4. Now we can draw the corresponding region in the w plane. So let this be the u and v axis. So the radius of the circle is 1 by 4 here. So I'll draw a circle with the radius 1 by 4. Okay, so let this be the circle. So the radius here, this point is 1 by 4. And the corresponding argument should lie between minus pi by 4 and pi by 4. So we'll draw the lines pi by 4 and minus pi by 4. This is pi by 4, the line theta equal to pi by 4, and consider the line theta equal to minus pi by 4. You can see that. So this angle is pi by 4 radians and this one is minus pi by 4. Okay. So the image of the region in the z plane, this image of this region in the z plane is interior of the circle mod w equal to 1 by 4, that is interior of this circle, together with argument lies between minus pi by 4 and pi by 4. So the corresponding region is this one, this which is the interior of the circle, and also argument lies between minus pi by 4 and pi by 4. So this region in the z plane is mapped to this particular region in the w plane under the map w equal to z square. Next problem, sketch the region 1 less than mod z less than 3. Argument lies between 0 and pi by 2, and find the image of the region under the map w equal to z cube. First, let us identify the given region. Given region is, when you consider mod z less than 3, it is the interior of the circle with center 0 and radius 3. So this is a circle mod z equal to 3 with center 0 and radius 3, and we are considering the interior of this circle. And in this part you have mod z greater than 1. That is, we have another circle with center 0 and radius 1, and we are considering the exterior of this circle. Okay, so actually this is a region considering in here 1 less than mod z less than 3. Now another condition is argument of the point must lie between 0 and pi by 2. So actually this is the region given. Argument lies between 0 and pi by 2, and the region 1 less than mod z less than 3. So this is the given region. You have to find the image of this region under the map w equal to z cube. So consider the map w equal to z cube, that is r e raised to I phi equal to small r e raised to I theta whole cube. So what happens is capital R becomes small r cube, and phi becomes 3 theta. Okay. Now the given region is 1 less than mod z less than 3, and 0 less than argument of z less than pi by 2. Okay. And what happens is here capital R becomes small r cube. That is, the amplitude becomes cube of the amplitude of the point in the z plane. So in the new plane, the w plane, the image becomes 1 less than mod w less than 3 cube, that is 27. And what happens to the argument? Argument becomes 3 times that of the point in the z plane. So you have 0 less than argument of w less than 3 pi by 2. Okay. Now it's enough to draw the corresponding region. Here the image is 1 less than mod w less than 27, which is the interior of the circle, mod w equal to 27, that is interior of this large circle, and exterior of the circle, mod w equal to 1, that is the exterior of this circle, that is this region actually. And the argument of the points must lie between 0 and 3 pi by 2. 3 pi by 2 means from here to here it is pi by 2, 2 pi by 2 and 3 pi by 2. So the image of this particular region in the z plane is set of all points in the w plane which lies here in this region. Another problem, 2 less than or equal to imaginary part of z less than or equal to 5. So let us denote the point z by x plus iy, and the point w, the image of this particular z w is equal to u plus iv. So the map given us w equal to iz, that is u plus iv becomes I into x plus iy. Okay, so this equal to ix, I square is minus 1, so minus y. So the corresponding point is u plus iv equal to minus y plus ix, or u is equal to minus y, and v is equal to the imaginary part here is x. So this is the image of the corresponding point x plus iy. The image is minus y plus ix. Now let us draw the corresponding region. So the region here is, let us see the right part, what happens. Imaginary part of z less than or equal to 5. Imaginary part of z means that y. Y less than or equal to 5. How can we draw this one? So let us mark y is equal to 5 first. So this is the point 5. Y less than or equal to 5 means that you are considering all the points below the line. This is the line y equal to 5. Let this be the line y is equal to 5. So it consider all points below this line y equal to 5. Now here it is given as imaginary part of z is greater than or equal to 2. That means y greater than or equal to 2. So let us mark the point y is equal to 2 here, and we will draw the corresponding line y equal to 2. So this is the line y equal to 2. So you consider all the lines with y greater than or equal to 2. So we are considering this part. above this line, all points above this line. Altogether, we have to consider all points in between these two lines. So what happens to the points in the image? Here, under the map, u is equal to minus y and v equal to x. It is given that 2 less than or equal to y less than or equal to 5. So it is given that u is equal to minus y and v equal to x. So u depends on y here. We have to compare what happens to u to the corresponding change to y. So minus y is equal to u. That means that here you can write minus 2 greater than or equal to minus y greater than or equal to minus 5. When you multiply with a minus sign, this inequality reverses. So you can say that minus y lie between minus 2 and minus 5. Or you can say that minus y equal to u, therefore minus 2 greater than or equal to u greater than or equal to minus 5. That means that u lies between minus 2 and minus 5. So let us draw this minus 2 and minus 5. This is u equal, this is the u axis and this is v axis. So this is the point minus 2 and this is the point minus 5. U equal to minus 2 means that you have a perpendicular line here. This is the line u equal to minus 2. This is u equal to minus 2. And we can draw another line u equal to minus 5. So let this be the line u equal to minus 5. So the image of this region in the z-plane is all points where u lies between minus 5 and minus 2. So this is the region which includes the image of given region. So these are the points which are the images of points of this region under the map w equal to iz.